So in last session, we have discussed some of the transformations. So some are left maybe today and when Friday also we are having session, right? By Friday we will complete all the transformations. Then we can start. It will take next 3 to 4 sessions. So 3 to 4 session we will discuss Databricks related topics. We have many things to complete like unity catalog, delta tables, internal tables, external delta tables, and CI/CD, and creating widgets, job scheduling. So many are there. Okay, so we will complete in next 4 to 5 sessions. I will take 2 hours time. Okay, okay. Yeah, transformations. Hmm. Okay, regarding. Okay. So we haven't discussed union. Yeah. So we haven't discussed union and union all and union by name. So first we will start completing this union of two data frames. Then we will move to other topics. So first one is union. So when you have two data frames, so if you want to create one data frame from both, I mean, so you if you want to combine two data frames and you want to create one resultant data frame, that time we will use this union or union by name. Okay. Yes, the union function. It is also one of the transformation. So it is used to combine the rows of two data frames with the same schema. Okay. So same schema means so we will use union or union all. Both are there. So this union all is deprecated. I mean, so now you have to use this union only. So it is deprecated. We will see. So union all is deprecated on our runtime or not because we are using 12.1, right? So you can use union or union all. Okay. So whenever the schema of the two data frames is same. I mean, number of columns and column names and order of the columns, everything should be same. Okay. Then only we can use union. Okay. So if the number of columns or order or anything data type is data type mismatch is there, then that time we have to use union by name. Okay, so we have two functions. One is union, other one is union by name. So when we will use union, so if the two data frames have the same number of columns and order of the columns also should be same. 1 minute. Okay, hi, Ranjit. Okay, Ranjit is from not from our batch, right? Okay, no problem. Yeah. So whenever the same number of columns and order of the columns are same, then we can use union. Okay. It combines two data frames with the same schema. Okay. So it removes duplicates. Okay. So if you want to remove duplicates, we yesterday, I mean, in last session, we have discussed, right? We can use distinct, I mean, distinct. So what it will do? So it removes duplicate rows. Okay. And so whenever you perform this union operation, it returns a new data frame with rows from both input data frames. Okay. Yeah. So the syntax is resultant. If you have df1, I mean data frame 1 and data frame 2, so the resultant will be data frame 3, data frame 1 union data frame 2. 1 minute, guys. Ranjit is pinging me. Tuesday, Thursdays. He's from April batch. So yeah, yeah. So the resultant data frame is DF3, and these are the two original data frames. You can use this DF1 dot this function union, and inside this you can give other data frame. Let's create two data frames with the same schema. I mean, same schema means same number of columns and everything should be same. Okay. Let me create data frame one first. So data one equals to uh, name and age. Okay, this one. And schema should be same, right? So I will use schema equal to struct type. We have struct type. Here, no need of struct type. We can use columns equal to name, comma, age, and data 2 equals to Charlie, age 35. df1 equal to spark dot create data frame, data 1 comma columns, and df2 equal to spark dot create data frame, data 2 columns. Yeah. So here you can see the order of the columns is same, name and age, and the data type also same, string and long, and number of columns also same. So here we have two, and we don't have any extra columns here. Okay, so now we can perform this union. Okay, df3 equal to df1 dot union df2 df3 dot display. Yeah, here you can see A and B, LS and Bob were in data one. Okay, so Charlie and David in data two, I mean data frame two. Okay, now we combined both of these using union. So this union will perform. So it will add the rows. So it will add the rows of both data frames if everything is same. So what happens if I give, so you can ask me, what happens, Gopi, if we give, okay, here, can I, okay, here, let me jumble this. So 40, first age and then name. So what happens? Here you can see, so LS and 25, Bob and 30, Charlie 35. So in name field, you can see age, and in age field, you can see name. So what happens? It won't throw error. The big problem is it won't throw error, but it process the data. So whatever it gets. So don't worry. It doesn't worry about this. Na. So what happens? It will process the wrong data. So in the name field, you will get age, and in the age field, you will get name. So it will process the data wrongly, and everything will I mean, so everything, the data, if you process it to some other system na, so there they will get wrong data. So that's why whenever you are using union na, that time please be cautious, so that everything should be, I mean, so schema should be matching. So the order of the column should be same, and number of columns should be same. So we have other function union all, right? So we will check. So union and union all both are same. Union all. Ah, it's working. So it work. Okay. So first I need to run this. Okay, so this union all was deprecated. Maybe we are using this Databricks, I mean Databricks Community Edition. I am using older version of Spark. So union all was deprecated. I mean, so it was used in older version of Spark. So now everyone are using union only. So you can use union or union all. So in, I mean, performance wise, there will be no difference. uh, Now we have union by name. Union by name. So here, this is more flexible. So whenever you are combining na, so you can use union by name instead of union. So it is more flexible than union. Okay, more flexible than union function, because so it combines two data frames based on column names rather than the order. Okay, so you understood, right? So what happens? It will, yeah, let me write here. It combines data frames based on the column name instead of order. So it will look for column names. If I give, I mean, so data frame one equal to name and age alias 25 Bob 30, and data two. So name, instead of name and age, you can use age and name 35 Charlie 40 David. So if you use the same union name, what happens? So you will get alias 25 Bob 30, 35 Charlie and 40 David. So if you use union, but if you use union by name, so what it does, so it won't look for order of the columns. It looks for the function union by name looks for so column names. So where it will match the column names, even though if you give a wrong order, so what it will do, so it will look on the column names only instead of order. We will see. And even if column orders are different, it aligns columns by name. Okay, even if column orders are different, it aligns columns by name only. Okay, so that's why the function name is column union by name. And 1 minute, guys. Yeah, sorry guys. So if we have in data frame one, we have three number of columns. In data frame two, we have two columns. Then you can use union by name. So what it will does, so for the missing columns, na, it will add null values. It won't throw error. So data frame one has three columns, data frame two has two columns. So it will do union. But so for the columns missing in other data frame, it will give null values. So, but if you use union, na, so it will throw error because we are missing the number of columns are not matched, na, so it will throw error. But union by name, what it will does, so for missing columns, it will give null values. So can ignore missing columns or allow missing columns using remember this one, you need to use allow missing columns equal to true. So we have to add this parameter so that, so if the number of columns are also does not match, so it won't throw error. Let me create one example so that you can understand much better. The syntax is same. So the syntax is df 3 equal to df1 dot union by name df2. Let me create one example for you. Yeah, let me take the same this data one equal to yes, column one equal to this, data two equal to 35, 35 comma Charlie, 40 comma David, column two equal to first age, right? Then name. Okay, let me create. Oh, sorry, it will throw error. Column one, column two. Yeah. Name and age. This one, age and name. Okay, nice. Now, if you perform df3 equal to df1 dot union df2, okay, so df3 dot show. What happens? Let's see. Sear, Alice Bob, and 3540, Charlie David. So it won't worry about the order, I mean, name of the columns. It looks for only order. So if I use union by name, union, so it process, if you use union, in this case, it will process wrong data. Now see, so even though the order of the columns are different, but it given correctly. So names are in one column and age is in one column. That's why. So when it is more flexible. And let me give, yeah, missing columns. Let me add one missing columns like, okay. So here, uh, age, okay. Mm, I will give only age. No, no, name only. So he in this data one what we have. So data one we have both name and age. In data two, so data two we have only name. Let me create these data frames. Mm, yeah, so it is tuple, right? We you under you if you remember, we have to keep comma here for tuple. Tuple will always expect this comma here. So in tuple, so you should not have only one item. So if you have only one item, that time we have to give comma. Now, if I use union by name, so let's see. So cannot resolve column name age among name. So here name and age were there. Here we have only name. So that's why it thrown error. So I told you, right. So whenever there are columns missing, that time we have to use this parameter. So allow columns missing, missing columns equal to true. If I add this parameter, now it won't throw error. See, so for first data frame, we have name and age. For second data frame, we have only name, right? So for age, it filled with null values. It won't throw error. Sometimes in real time it happens. So sometimes what happens from data, if you have data stores, I mean, if you have stores like DMart stores like two or three, so you are getting data from those two or three stores, but it is not guaranteed that so those DMart stores will have the same fields and same number of columns. Maybe store number three can have extra columns. They may include feedback, users feedback also. So store one and store two, they are not taking users feedback. Then that time, if you use union by name, okay, so union by name, if you want to combine all stores data into one Excel sheet or one file, that time you will use union by name. And if you don't, you can use this allow missing columns equal to true. So for other two stores, feedback column will be null. For third store, they are maintaining feedback, right? So for them, the default value, I mean, the original value will be there. So it happens in real time. So it happens that then that time you can use this allow columns missing columns equal to true. This parameter you can use. So this is the, yeah. So in whenever you want to combine the data frames now, so you can use this union or union by name. So I suggest you to use union by name. So irrespective of column order or missing columns and everything. So it is more flexible. Okay. So you can use union also if you know. So everything is good. So number of columns is same and order also same. If you are if you have I mean if you are confirmed with the data, then you can use union instead of union by name. And if you are not sure and if you want more flexibility and some columns are added in between whenever you are processing the data, some columns are added in one of the data frame, then that time you can use this union by name. So it is up to you. Yeah. And now next one is group by. Guys, if you have any questions regarding this, we can discuss for 1 or 2 minutes. Otherwise, we can move to other transformation group by. Yeah. So many we already discussed while discussing SQL basics. Na SQL basics, we discussed group by function, but now we will discuss in detail. So group by means whenever you have some column like department column, so you are maintaining employees data. So but in department column you have several departments like HR, IT, and sales, marketing. Okay, so you want only HR data, or if you want group by. So group by data, I mean, so from the employees table, you want only HR count and IT employees count. Then that time you will use group by. So this, yeah. So let me explain what group by function is. The group by function is used to group rows that have the same values in specified columns. So you understood, right? So you have employed all employees data, but you want to perform, you want to group the department wise, or if you want to group by what role wise, I mean. So in the employees, we have data engineer, data analyst, and data science. So if you want to group by the role, so then you can use this group by function. On top of this group by, so you will get resultant data frame. Na? So on top of it, we can perform aggregate functions. So we'll see. So maybe it is not, maybe. So whenever I explain with some examples, na, then that time you can understand better. So the group by function is used to group rows that have the same values in specified columns. Okay. Mm, After grouping, we can perform, yeah. So after grouping, what we can do? So we can perform aggregate operations like count, sum, average, minimum, maximum. Okay. Some aggregate functions are common aggregate functions are some aggregate functions. What are the aggregate functions? Count, sum, average, mean, minimum, maximum, or distinct count. If you want to take distinct count, you can use this function, and first value and last value in the group. So these are some of the aggregation functions. We will discuss everything in detail now. Okay, so first let me create one data frame. So I will explain how can we perform group by function along with other aggregate functions. Okay, data equals to Anil. So here we have department and his salary. Okay. Control C, Control V, Control V, Control V, Control. Yeah. Next one, Bobby, and he belongs to IT department, and his salary maybe 4,000. Okay. Uh, Shari, he also belongs to IT, and his salary is maybe 4,000. And we have uh, David. He belongs to HR and his salary is 2,000 rupees. We have Eric. He belongs to finance. His salary is 5,000. And also we have what? F. Okay. Farouk. Farouk. He belongs to finance and his salary maybe 4,000. Okay. And last we have Gopi. He belongs to IT and his salary maybe 3,000. Okay. And columns are first one name, second one department. Okay. And the last column is salary. Let me create this data frame. Data frame equals to spark dot create data frame data columns df dot show. Okay. A, B, C, D, E, F, G, HR, IT, IT, HR, finance, finance, IT. Okay. 3, 4, 4, 2, 5. Yes. Correct. So now I want to. So what I want, so maybe so they have given employees data like this. So all the employees and their salary and their department they have given. So maybe they ask you to count of employees per department. So they have asked you. So they leadership won't don't so maybe in one organization so 1 lakh employees can be there, 1 to 2 lakhs. If it is MNC, so maybe 10 lakh employees can be there na? So what they want, so they don't want this all the employees information. So the leadership want to know, so how many employees per department they want, that aggregated data. So that time you can use this group by. So this group by function, what it will do, so it will so if in the column if we have specific same values as rows na, then that time we can use group by. So what it will do now, so in this column, department column, we have same values like HR, IT. So this one, so we can do the group by department, right? So what happens? So these HR people, I mean Anil and David, they will be in one group, and IT people, Bobby, Chari, and Gopi, they will be one group, second group, and finance. So we have third one is finance, right? Third department. So Eric and Farouk, so they will be one group. So now we have three groups. So what they want, employees count, okay, per department. So three departments, so three rows, and the count. So the count will be 2, 3, and 2. So HR 2, IT 3, and finance 2. So how can we do this one? We can do achieve this by using group by. So df dot group by, and group by which one, department column, right? So on top of department column we can apply this function. So it will group the same rows means HR. So this HR and HR is same row, right? Same value, right? So this one be one group, group one. And IT, these three rows will be in second group. As finance and finance, this one will be in third. So on top of this one, so df dot group by department. So now it group by department has done. So you want count, right? So count. Let's see. Yeah, department and their count. So in HR department, how many employees are there? Two. IT, three, right? Three employees. Finance, two. So we can perform. So whenever you want to perform aggregate functions, right? So that time we can use this group by. So group by along with aggregate functions. So count is also one of the aggregate function. Okay. And now if you want to know, so if you want to know total salary per department, not per employee, per department you want to know. So HR department was there na. So for HR department, what was their total salary? IT employees, three IT employees are there. What is their total salary? Finance people, two people were there. What was their total salary? Then that time, so DF dot group by department only, because we want a salary per department, right? So group by department dot, so what we can do, some function we can use, sum of salary, right? We want what we want, total salary, right? Total salary is nothing but sum of the salary. Dot show. So department and some salary. Okay, HR people, how many people we have? Two, right? 3,000 plus 2,000, 5,000. Yeah, here 5,000. IT 11,000. IT 4 plus 4 8, 8 plus 3 11. Yeah. So finance 5 plus 4 9. So maybe they will ask you, leadership will ask you to provide me. So I want department wise salary, total salary per department I want. So then that time you can use group by department and sum of the salary. If you want to know, so average salary per department, that time what you can do, so in place of sum you can give this average function. So here you can see, so HR people, how much their total salary from 5,000, right? So average salary will be 5,000 by 2, 2,500. IT, so 11,000, right? 11,000 by 3. So 11,000 by 3 is this much. Finance, we have 9,000, 9,000 by 2, 4,500. So you can find, so which they want to know. So which department has more average salary they want to know. So then that time you can perform this average salary. And if they want to know maximum salary and minimum salary, okay. So maximum salary and minimum salary per department, if they want to know. So you can use maximum function here. IT will have maximum salary. Yeah, HR. Okay. So maximum salary in HR is 3,000 and 2,000, right? 3,000. In IT, 4,000, 4,000 and 3,000. So 4,000 is highest. Finance, so 5,000 and 4,000, right? So 5,000 is highest. So if you want to find minimum salary per department, Okay, so you can give here 2000, 3000, and 4000. You can compare with this. You can compare with original data. So in HR, minimum is 2000. In IT, minimum is 3000. In finance, 4000. 2, 3, 4. Yeah, 2, 3, 4. Like this, you can perform. So you can use group by function, and along with group by, you can use aggregate functions to perform this. So you can ask me, Gopi. So if I want, if can we achieve this one in single transformation? Yes. So multiple aggregation we can perform using AGG function. Okay, aggregate function. We can use AGG this one. After group by, you can use this aggregation function. So we can do multiple transformation in the single multiple transform aggregations with the single transformation. Okay, so df dot group by group by. Okay, so group by department column, right? Department column dot we want to perform multiple aggregations, right? Aggregations. Okay. Mm, so first aggregation can be count. So count of the total employees. Okay. Count of the all employees. Alias we can use, we know so how to use this alias function. Alias what I can do, employee, this one, employee count. Next transformation, sum of the salary, sum salary. I want to give alias total salary. And if you want to perform average salary, okay, I can use this one now. Average, average, here also average salary. Okay, so I want to perform multiple aggregations using single transform. We can use AGG. Name count is not defined. Count name count is group by department aggregations. Okay. Hmm, dot alias employee count should work. Name count is not defined. What? Wait 1 minute. Hmm, it should work. Unsupported operand types plus unsupported operand types for plus int and string. Df dot group by department. Okay. Dot aggregations. It is correct only. Some salary. Okay. Tap and here. Unsupported. Different types. Aliens. It should work. What is the problem? Type error. Some salary. Salary. It was there, no? DF dot show. Hmm. It's correct only. Hmm. DF dot group by correct department. Correct dot aggregations. Correct sum salary alias total salary. This is also correct. Average salary. This is also correct. Why it is throwing error? DF1 equals to. Hmm. String object has no attribute. Okay, let me remove this. Spark dot SQL dot functions import all. Okay. Control. Okay. Okay. The problem is, so we have to import all the functions. That's why it is throwing errors. Okay. So whenever you are developing now, so whenever you are writing anything, so use both of these. Import all the functions and this one also from PySpark dot SQL dot types import all. Okay, so if you want to perform multiple aggregations, now then we can use this aggregate AGG function. So I want to know, so how many group by department, how many people are there in each department. So this is the employee count, total salary, this much, average salary. If you want to perform minimum salary, maximum salary, and any number of aggregations, if you want to perform inside this one, you can use. They have to separate it by comma. So you this one. So what you can perform any number of transform aggregations using this AGG. Okay, what we can do? Mm, mm. We can perform this group by on multiple columns also. Let me do this group by what department and salary also. So department and salary, and I want to know count. Done. So I will explain what this is doing. Let me run this one first. So here, how many it is performing group by, right? So in in original data frame, how many rows we have? 7 rows. But here, how many rows we have? 6 only. because so we are doing group by with department and salary. So here you can see IT and IT. So they have 4,000 and 4,000, right? So now we are grouping both department and salary, right? So here HR 3,000 and HR 2,000, both are different. That's why they will not come into one group. Okay. So that's why HR 3,000 and HR 2,000 are two separate groups here. If you see HR 3,000 and HR 2,000 are separate groups. Okay. And next one, mm, IT, HR, HR, IT, IT, finance, finance. Okay. Okay, okay. Understood, understood. So here HR 3,000 and HR 2,000 are two different groups. That's why we have two columns for it. So here you can see IT, IT, IT. So now group by both department and salary, right? So IT 4,000, IT 4,000. So these two are in one group. That's why IT 4,000 we have count two. So IT 4,000 count two, and we have one more IT field, IT 3,000. So IT 4,000, IT 4,000, and IT 3,000. These two are in one group, and this is different, right? That's why it is in other group. You can see IT 3,000 with other group, that count is one. And finance, we have both people, and they have finance 5,000 and finance 4,000. That's why both are different, right? So if you perform on only one group, one column, so then that time HR both are same one group. IT, one group. Yes, these three are in one group. Finance, one group. But we are performing group by and two columns, HR and salary. So HR, HR, not HR, department and salary. So department and salary, both columns should match. So where they are matching, so only here. So only IT 4,000, OT 4,000 are matching. That's why they are in one group. So second, three, four, five, six. That's why we have six rows here, and IT 4,000 count is 2. So you can perform like this also. So whenever this gives how many employees in each department earn a specific salary. So this, if you want to know, so how many employees in each department earning a specific salary, that time you can use group by department and salary. Here you can see IT 4,000 is 2. So it is not specific, right? So it is repeated. IT 4,000 is repeated. That's why it is in one group. Remaining all are employees with specific salary, and it by department. So we can group on multiple columns also. Okay. Mm, and next one, next transformation, we can use select. So it is same like in SQL how we use select. So it will select specific columns, right? Here also we will use it will perform the same operation. So the select function is like same like in SQL we have select class, right? So same like it will perform. So it is used to select one or more columns in a from a data frame. Okay. It is similar to, yeah, it is similar to which one? Select clause in a SQL. So the syntax will be data frame. On top of this data frame will apply this function, right? So df dot select, how many columns you want to select? Column one or column two. Yeah, this is the syntax. Hmm. Hmm. Let me use the same data frame here, same data. What we have? Name, department, and this one. Let me add age also. age column also. 30 here, 35 here, 40 here, 29 maybe. Uh, Eric, Eric, how much? 50. Okay, let me remove these two. Okay, Anil 30, HR 3000, Bobby 35, IT 4000, Chari 40, IT, okay, same na 5000, David, finance, HR, finance, okay, maybe 3900, like, okay, mm, okay, and last one, Eric 50, and maybe HR 1800, yeah. Name, and we want to you include one more, right? Age, name, age, department, and salary. Okay. Okay, name, age, department, and salary. If you want to select only, if I want to select only one, this one column, df dot select, you can directly you name the column name and let show. So I want to select only name column. Then you can select only name. So if you want to select all the columns, you can use this. No, it is not valid. If you want to select multiple columns, uh, it work? Yeah, it will. So in SQL, select star from the table, right? So here you need to pass inside this one. It will allow string only, string object. That's why inside this one, inside this star should be surrounded by this double quotes. Okay. If you want to select all the fields, then you can use this star. Okay, otherwise, if you want to select some specific columns, you can select. Okay, if you want to select name and salary, okay, name and salary, you can select like this. Okay, and if you want to change the name, so using select also we can change the name. I mean alias function we can use here, like df dot select. Okay, so name. Okay, this column name. So on top of it, we have to perform, right? Alias employee name, and remaining same. I want to change only the name field, and I want to select all salary also. So you can use, so to change the column names, inside this select function also we can do this using alias function. So here you can see, so the same data frame here and here, but what I did, I want to change this name to employee name. Okay, so we can do like this. We can use alias function, and okay. Mm, and if you want to perform some if you want to perform some expressions inside select, so we you can perform also. I mean, so if you want to add 1,000 rupees to salary column, or if you want, if you got hike, so every employee got hike up 10%. So how can we do this? Df dot select. So I want to select name field and the salary also, column salary also. But what I want to do, so I want to add 1,000 rupees to column, this salary column. So you can perform. So you can perform some expressions also. Here you can see. The original one, we have 4, 3, 4, 5, right? Here 4, 5, 6 because we have added 1,000 rupees to this column salary. So if you want to perform some expressions inside the select, we can perform. Okay. Okay. Mm, and so okay, but this should not be it. So you can ask me, Gopi. So it is giving salary plus 1,000, right? We can what we can do? Column salary plus 1,000 dot alias. Let's try. No, no, no. Control Z dot alias salary only. See here, so we can use aliasing function. So we performed some expression, we have added, we have I mean we have manipulated this one, modified this column salary, and if you want the same color, same name, you can use same column name. And if you want salary new as column name, you can give. Okay, so like this, we can perform some expressions also inside the select. Okay, and if you want to perform some operations, like if you want to convert name to the uppercase, so we can perform inside select also. Df dot select. You can use this upper, right? Upper on what, on top of this name, right? Dot show. Here you can see. So yeah, so Anil, Bobby, Chari, David, and Eric. So we performed this on top of this column name. We performed upper function. So it converted all names to uppercase. If you want to give some alias name, here you can give. So dot alias name only. Otherwise, new name. Or if you want to give any name, any column name, you can give. Mm, yeah. So in selecting only, mm, in select only we have select expression, I guess. Let me check this one. Hell, no, no, no. Select df dot select. Yeah. So we have select expression also. So we have both select and select expression. This one we can use directly. I mean, mm, how what to say? Mm, mm, select expression. How can we use? Okay. So if you have expression, you already know. So you want to perform some expression inside this one. You can use select expression. Like, so I want to first I want to select name. Okay, name, and next I want to perform some operation on salary column. So how can we do? So salary I want to multiply. I got hike of 10%. So I want to multiply this one with 1.1, right? So 10%. Yes. Incremented. Let's try this. I am not sure how it is going to work. See here. So it will work. So select expression, it is like SQL. Okay. So it is SQL expression only. Inside this, you can write SQL query. So in SQL query also, we will use this as, right. So in PySpark, on top of PySpark, we have to use alias. But this one, whenever you use this select expression, it is like SQL query only. So first field is name field I want, and second one, on top of this one, I want to perform a mathematical operation. So that time you can use directly this select expression. Okay. So select you can use and select expression you can use. So whenever you use select na, so we perform the same thing. But here you can see, so on inside this, we are adding some expression. Okay. Here also directly you can use select expression function. So the difference is here you can directly use SQL like query. So it is not PySpark commands. This is SQL query. Okay. So when if you are comfortable with the SQL queries now, then you can use select expression directly select the expression function. If you are comfortable with PySpark coding, so you can use select and inside this you can write Python related script. If you are good with SQL, you can directly use select expression. Inside this one, you can write SQL type of queries. So only this difference, nothing, no, uh, no difference in the performance. Only so which one you are comfortable with. If you are comfortable with Python, you can use select. If you are comfortable with SQL, select expression function you can use, and you can write select SQL queries. Okay, so what we can do, so it is not only for selecting columns, we can rename the function and we can modify the existing columns. We can perform some operation inside it. Okay, we can inside select function only, we can perform some operations also. And we can change the, I mean, we can apply some built-in functions. Okay, like upper, lower. Okay. Okay, so today what we have discussed so far, union and union by name, and next group by and all the aggregation, mean most of the aggregation function, and select function along with select expression also. Mm, yeah, what we can do, we can discuss joins. We can discuss some of the joins. Okay, we have time, right? Yeah, joins. We have, so in SQL also we have so many join types, right? Inner join, left join, right join, full join. Okay, he in PySpark also we have some join types: inner join, right join, left join, full join, and left semi, left anti, and cross join. We will discuss everything in detail. Okay, so what is join? So why we use these joins? Okay, so in Databricks, joins in is allow you to combine two data frames based on a common column. Okay, we will have one common column. So based on that common column, we can combine both data frames. That time we can use this join. Okay. Uh, okay, so let me try it here. Joins in Databricks allow us to combine two data frames based on a common column. Uh, I mean, so we will have one data frame, left data frame, and we will have other data frame, right data frame. Think like left table and right table. So we will have common column between both of these. Maybe customer ID in both of these. So you can have employee information in one column. Okay, no. Sales information in one column, one table, and sales information in one table and customers information in one table. So the we should have one common column, right? So in sales information we will have customer ID, right? So in customer table also we will have customer ID. So we will use this common column to combine both of these tables. So same like SQL here also. So we will have some one primary key here. So in we can say common column. Okay. So using that common column, we will combine these two data frames. First one is inner join. So it returns. So if you perform in inner join between data frame 1 and data frame 2, so what it is going to do, it returns only the matching rows. So it will return you matching rows only. Okay, it will return matching rows between two data frames based on the join condition. So we will use join common column, right? So that on the using that common columns, so which rows are matching, those rows only it will return. Okay, the syntax will be df1 dot join df2. So the one, so the df1 which is which we are using first now, it will be left data frame, and inside we are giving now that one will be right data frame. So df1 join df2, and the condition. So what common column you are using, what condition you are using, that is second parameter, and third parameter will be join type. Join type means inner or outer or left or right or, so that one. So the syntax will be same for the all the joins. Okay, df1 dot join df2, and the condition and the join type. So you will understand better if you, if we create this one, what if you have data. So I will explain with the data, then that time you will understand much better. Let me create data frame 1, 1a, 2b, wait, 1a, 2b, 3c. Data frame 1, and column 1 is id and name. We have data 2. Inside data 2 also we have id 1, and second column is category. Okay, xyz are category, abc are names. 3y and 4z. Column 2 equals to id, the common column name is this one, id and category. Okay, so we have two data frames. One is data one, this one. Let me create data frames first. df1 equal to spark dot create data frame d1 comma c1. So in data frame 1 we have id and name. So ids are 1 and 1 2 and 3, and abc are the names. Let me create data frame 2, spark dot create data frame D2. So D2 and C2. So in data frame 2, we have name and category. Okay. So 1 3 4 are IDs, and XYZ are categories. df1 dot show, same df2 dot show. 1 2 3 ABC, 1 3 4 XYZ. Okay. So let me perform this inner join. Okay. Inner join. So df inner equals to df1 dot join df2, right? df1 dot join df2. So df1 is left data frame, df2 is right data frame. So that condition we have to give, right? So df1 dot id equals to df2 dot id. So on id column I am performing. So if from the data frame, left data frame, if and data frame 2, if both ids are there, then perform the join. So which join? Inner join. Let me print, show this df. See here. So how many IDs are matching between these two? One, yes, we have one. This is matching. Two in left data frame, we don't have here. Three is there. Yes, three is there. Okay. Four, it is there, but it is not there. So which are matching? One and three, right? So one and three, AC, one, three, AC, XY, right? One, three, AC, XY. So same we got, right? 1, 3, AC, XY. Yes. So it returned only the matching rows, right? So the inner join will from the it will compare two data frames and it will return you the only matching rows. Here, what rows are matching? So 1 and 3 IDs are matching. Here 1, 3, here 1, 3. So these two are matching. That's why it returned 1 and 3. So you can ask me, Gopi, why we have this ID two times? So sometimes what happens? So from the left data frame, this ID name can be different. So they can use ID1 here. They can use ID2 here. But what they will say, this is the column, this one, a common column. ID1 here, ID2 here. That time what you can do? So df1 dot id1 equals to df2 dot id2 you can use. But in this case, both IDs are same. So to remove the duplicate columns, what we can do? We can directly give the condition ID here. Now, so we have only one column, right? ID column. So one three columns, one three IDs are matching, and their names and categories, respective names and categories are displayed here. So this one df1 dot id equal to df2 dot id. So we can use, but what it is doing, it is duplicating the IDs. But it will be useful whenever we are giving. So this ID name, this ID, both IDs name column names are different. Then that time you can use df1 dot id1 equal to df2 dot id2. Otherwise, if both are same, directly use this condition. On top of this ID column, we are matching it. We are using this condition. You can directly give the column name. If both data frames has same column name, you can directly give the column name. If they are different, column names are different, common column names are different, then you can use df1 dot column 1 name and df2 dot column 2 name. Understood? Any doubts in this? Because this is the first join type, right? So if you understand this one, then other types will be very easy. So why we use this join? Whenever you are you want to combine two data frames, that time if you have common column between those data frames, then we can combine using joins only. Okay. And so the syntax is this one. The inner join will, what it will return us. So the inner join will return us the only matching rows. Here the matching rows are 1 and 3 IDs. Okay. If you understand this one, then I will move to next join type. If you did not understand, you can ask me, because so joins are in every interview. So you will have at least one or two questions on joins. That's why. So they will ask you questions related to joins. If you understand this one, I will move to left join. Okay. So the left join, what it is going to do, the left join will return all rows. It returns all rows from the left data frame. Okay. So it is going to return all rows from the left data frame and only the matching rows from right data frame. I mean, so we will have non-matching rows, right? Non-matching rows from the right will have null values. You understood what does it mean? So it is going to return all the rows from the left table only. So left table means 1, 2, 3. ID is 1, 2, 3, right? So 1, 2, 3 ABC only. Okay. So it is going to return the all the rows from the left data frame and the matching rows from the right data frame. Means so here it is going to return only 1 and 1, 2, 3 only. So 1, 2, 3 ABC and the category will be so for one A we have right for one we have category X. So 1AX will be the first row and 2B it is going to return all the rows from left table, right? For 2B we don't have any match, right? For 2 we don't have any match. So 2B and null and 3C, yeah, 3 for 3 we have, right? And 3C and Y. Understood? Any doubts here? So the left join will return you all the rows from the left table, left data frame, and the matching rows from the right. So here for 1 and 3 we have matching, right? So X and 1 and 3 means X and Y. For 2 we don't have any matching. For this we will get null value. If I print the result, you may understand better. df uh, left right df left equals to df1 dot join df2 I and id only and left. So it is going to return, so the left join will return all the rows from the left data frame, and if we have matching rows from the right data frame, this will return. If we don't have a non-matching rows from this, null value will be given. So 1 2 3 we will get. Yes, 1, 2, 3 we will get. For 1 and 3, we know. For 1 and 3, we have match from right data frame X and Y. We don't have this one. For 2, we don't have in right data frame. That's why it is filled with null. Understood? Any doubts here? So how left join will work? It is going to return the all rows from the left only. So this one, ID and name, right? So 1, 2, 3 from left only. 1, 2, 3 from left. ABC from left, and from right data frame we have to match category, right? So if there is match from right data frame, it will match. So for 1 and 3 we have matched, that's why X and Y. If non-matching rows will return null values. 2B is non-matching, that's why null values. So right data frame. If you understood this one, I will go to right join. Any doubts here? Don't worry, guys. So I will take a real-time example and I will explain everything tomorrow also. But today you know how these joins will work. Tomorrow for first 5 to 10 minutes, we will take some one real-time example and I will show you. Don't worry. So the right this right will be opposite to this left. So I mean, so return all rows from the right data frame. So it is going to give all the rows from right data frame and only matching rows from the left data frame, and non-matching rows from the left data frame will be have null values. Okay. Df right, df right. Okay. And here right. It means so now it is going to return you. So what in the right data frame, what we have 134, right? So 134 and the category will be XYZ and the name will be so which are matching 1 and 3, right? So for 1 and 3, A and C names will be A and C, and this is non-matching row, right? So for Z and null value. So it is going to right join will going to return you all the rows from the right table and the matching rows from the left, and non-matching will have null values. Let's see. 134 we will have. Yeah, 134 we will have, and category will be XYZ, and the left data frame we have name, right? So which are matching, 1 and 3 are matching and their values are A and C. 4 is not matching, that's why it is null. Any doubts, guys, till now? Guys, please respond. Any one of you, because this is very important topic. Joins is very important topic. If you understand, so you can answer in interviews.
No, no.
Everything is okay.
Everything is okay. Good, good. Thank you. Okay, okay, guys. So next one is full join. So this full join is nothing but what combination of both right and left join only. Okay. So what it is going to do, it return all rows from both data frames. Okay. It returns all rows from both data frames. So and if there is no match, null values will be placed. Okay. I mean, so how many IDs we have? One, two, three, four, right? So from left data frame one we have one, two, three, and right data frame we have one, three, four. So a total how many are there? One, two, three, four. So full join will give you all the rows from both of these. So we have four, right? One, two, three, four we have. So name. So here name will be so 1A, 3C, 1A, 3C, right? 1A, 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 X, 3C, Y. And for 2B, we don't have match in right. So for 2B, null, and 4Z also null. Okay, so it is going to return all the rows from both of the data frames. If there is no match, it is going to fill with null values. Otherwise, what we can say, it is combination of both right and left. So combination of both right and left joins. So here you can see 1AX is there, 1AX will be there. And 2B null, yeah, it will come. 3CY is there, 3CY is there. 4 null Z, so 4 null Z will come. So how many are there? Distinct value. 1AX is one and 2B null is second one. 3CY is third one. This is repeated. This is repeated. 4 null Z is other one. So we will have four values. Okay. So for 2B null and 4 null Z, we will get. It is nothing but combination of both right and left. Otherwise, what we can say, so it is going to return you all the rows from both data frames. If there is match, no problem. If there is no match, it is going to return you null values. How many here, right? Not right. Full join, right? Full join, full. Here, see, so it has returned everything, right? So from data frame one, we have one, two, three, and from data frame two, we have one, three, four. So it has returned all the rows from both of these data frames. So we for one and three, we know for one and three, we have matches. So that's why 1AX, 3CZ, 3CY. For 2B, we don't have match from this one. That's why null. From 4Z, we don't have match from a left table. That's why null. So it is combination of both right and left joins. So if you understand well and good, so tomorrow we will see one real-time example. Okay, I mean we can take sales data or some orders data. So customers and orders data on top of those data frames, we can see how to perform these joins. And we have left semi and left anti also. Tomorrow I will explain left semi, left anti, and then we have cross join also. It is nothing but Cartesian product like thing. And we have broadcast join also. In many interviews you will come encounter this question, why we use broadcast join. Okay, so tomorrow maybe first for 10 to 15 minutes we can see that example. So it may be confusing now. So tomorrow I will explain with real time data. That time you will understand much better. So inner join will give you matching rows from the both data frames, and left join will give you all the rows from left table. And if there is match from right, it is okay. Otherwise, null values. Right join, it gives all the rows from right table, and if there is match from left table, okay, otherwise it will fill with null values. And full join is nothing but combination of both of this. Otherwise, what we can say, it will give you all the rows from both data frames. If there is no match, it will fill with null values. If you have any doubts, we can discuss for